You have just stepped out of a long, hot bath. Or perhaps you have spent an hour in a swimming pool. You look down at your hands, and there they are. Your fingertips have turned into tiny prunes, wrinkled, shriveled, strange. You have probably seen this happen hundreds of times in your life, and you have almost certainly heard someone explain it this way. Your skin absorbs water, swells up, and that causes the wrinkles. That explanation is everywhere. Parents tell it to their children. Friends repeat it in locker rooms. It feels correct. After all, when you put a sponge in water, it swells. When you put a raisin in water, it plumps up. So surely, when you put your fingers in water, the outer layer of your skin simply soaks up the moisture and expands, creating those familiar ridges and valleys. But here's the problem with that explanation. It is wrong. In fact, it has been known to be wrong for nearly 100 years. And the real reason your fingers turn into prunes is far more surprising. It involves your nervous system, your blood vessels, and an evolutionary secret that scientists are still debating today. Let us go back to the beginning of this discovery. In the 1930s, researchers made a fascinating observation. They noticed that patients with certain types of nerve damage did not develop wrinkled fingertips when their hands were submerged in water. Their fingers stayed completely smooth, no matter how long they soaked. This was a critical clue. If the wrinkling were simply caused by water absorption, it should happen to everyone equally. Skin is skin. Water is water. But here were people whose fingers refused to wrinkle at all, and the common factor among them was damage to their nerves. Specifically, the researchers found that patients with median nerve palsy, a condition where the median nerve in the arm is damaged, could not produce wrinkles on the affected fingers. In 1935, scientists named Lewis and Pickering published their findings on this very subject. They had discovered that normal skin wrinkling after water immersion requires functional nerves. Later studies confirmed the connection. In 1973, a researcher named O'Ryan reported that denervated fingers, meaning fingers with severed or damaged nerves, showed no wrinkling at all. Even more compelling, when those same nerves were repaired or regenerated, the ability to wrinkle partially returned. This was the first major blow to the old absorption theory. If wrinkling were a passive physical process like a sponge soaking up water, nerve damage would not matter. But it clearly did matter. The wrinkling was not happening in the skin cells themselves. It was being controlled by something deeper. So what exactly is happening inside your fingers when they turn into prunes? The process begins with your sympathetic nervous system. This is the part of your nervous system that operates without your conscious control. It regulates your heart rate, your breathing, your digestion, and your body's famous fight or flight response. When you are scared, your sympathetic nervous system is what makes your heart pound and your palms sweat. You do not tell it to do this. It just happens. And according to modern research, your sympathetic nervous system is also responsible for your pruny fingers. When your fingertips are submerged in warm water for several minutes, your sympathetic nervous system sends a signal to the blood vessels deep beneath the skin of your fingers and toes. That signal tells those blood vessels to constrict, meaning to become narrower. When the blood vessels narrow, the volume of blood in your fingertip decreases. The soft tissue of your fingertip loses bulk. The skin on the surface, however, does not shrink. It stays the same size. So the outer layer of skin, which is now too large for the shrunken tissue underneath, buckles and folds. Those folds are the wrinkles you see. Think of a grape shrinking into a raisin. The skin does not absorb anything. The inside simply gets smaller. This is the mechanism. Your nervous system triggers blood vessel constriction. Blood vessel constriction reduces fingertip volume. Reduced volume causes the skin to wrinkle. But this discovery immediately raises a much bigger question, a question that scientists have been debating for years. And that question is, why? Why would your body have evolved a specific nerve-controlled mechanism to make your fingers wrinkle in water? What possible benefit could there be? It is not for warmth. It is not for protection. And it is clearly not an accident, because accidents do not require a carefully controlled nervous system response. So there must be a purpose. There must be a reason that your body goes through this process every time you stay in water long enough. And that reason, according to a growing body of research, is grip. This brings us to the second part of our story, because the answer to why your fingers wrinkle may have more to do with survival than you ever imagined. We have established that your fingers wrinkle because your sympathetic nervous system constricts your blood vessels, reducing fingertip volume and causing the skin to fold. It is not water absorption. It is nerve-controlled vasoconstriction. But that discovery only leads to an even more interesting question. Why would evolution create such a mechanism? What possible advantage could wrinkled fingers provide? In 2011, a theoretical neurobiologist named Mark Changizi proposed an answer. Changizi was working at 2 AI labs in Boise, Idaho, and he had stumbled upon those old 1930s papers about nerve damage and wrinkling. Those papers immediately suggested to him that pruny fingers were not a random side effect. They were functional. They served a purpose. Changizi gathered his team, including a student named Roman Weber, and they began to think. Weber asked a simple question. Could they be rain treads? The idea was elegant. When you press your finger onto a wet surface, water gets trapped between your skin and that surface. That water acts like a lubricant. It makes things slippery. If you have ever tried to pick up a wet bar of soap or open a bottle with wet hands, you know exactly what this feels like. Your grip fails because the water is in the way. But what if your fingertip had channels designed specifically to drain that water away? What if the wrinkles acted like the treads on a car tire? Tire treads are not decorative. They exist to channel water out from under the tire, allowing the rubber to make direct contact with the road. Without treads, a car would hydroplane on wet surfaces, losing all grip. Changizi proposed that wrinkled fingertips work exactly the same way. The grooves in your skin act as drainage channels. When you press your finger onto a wet surface, water is forced into those grooves and away from the points of contact. This allows the raised ridges of your skin to touch the surface directly, giving you a much better grip. To test this idea, Changizi and his colleagues reverse-engineered the wrinkling pattern. They wanted to see if the pattern matched what you would expect from a drainage system. It took them a year to figure out the best theoretical shape, and what they found was striking. The pattern of wrinkles on a soaked fingertip looks remarkably similar to the river networks on a mountain range. Rivers gather at the peaks and flow downward, with the divides in between acting as drainage channels. Your finger wrinkles do the same thing. They channel water away from the points where you need the most friction. This was a compelling hypothesis, but it needed experimental proof. And in 2013, a team from Newcastle University in England provided some of the first evidence. The researchers designed a simple experiment. They asked volunteers to pick up wet marbles using either dry fingers or fingers that had been soaked in warm water for 30 minutes until they were fully wrinkled. The volunteers then had to transfer the marbles from one container to another. The results were clear. People with wrinkled fingers could pick up the wet marbles significantly faster than people with dry fingers. And here is the crucial detail. This advantage only applied to wet objects. When the marbles were dry, both wrinkled and unwrinkled fingers performed equally well. This suggested that wrinkled fingers provided a specific benefit only in wet conditions. Exactly what you would expect from a grip-enhancing adaptation. The experiment was repeated. The findings held up. Wrinkled fingers gave people better traction on wet surfaces, allowing them to grip and manipulate objects more effectively. There was, however, a competing study that complicated the picture. In early 2014, scientists at the Max Delbruck Center for Molecular Medicine in Berlin attempted to repeat the marble experiment. They found that having wrinkly fingers made no difference in how well people could grip wet or dry objects. The science was not entirely settled. But even with this debate, the grip hypothesis remains the leading explanation for why this phenomenon exists. Researchers have noted that the wrinkling does not begin immediately upon contact with water. It takes about 5 minutes to appear. That delay is important. If your fingers wrinkled at the slightest touch of moisture, they would be wrinkled constantly. Rain would do it. Washing your hands would do it. Dew on grass would do it. By requiring a longer immersion, your body reserves this adaptation for situations where you are genuinely in a wet environment for an extended period, such as when you are wading through water, gathering food from a stream, or trying to climb out of a flooded area. There is another clue that supports the grip hypothesis. Pruney fingers only occur on your fingers and toes. They do not occur on your arms, your legs, or your torso. Why? Because your fingers and toes are the parts of your body that you use to grip things. Your arms do not need to grip slippery surfaces. Your toes, especially for our primate ancestors, were also used for grasping branches and climbing. Evolution focused the adaptation exactly where it was needed. The grip hypothesis even has a name among scientists. They call it the rain tread or river drain hypothesis. The wrinkles are not random. They are designed. Now, let us step back for a moment and appreciate the full arc of this story. For decades, perhaps centuries, people believed that Pruney fingers were caused by simple water absorption. It seemed so obvious that no one questioned it. But careful observation of patients with nerve damage revealed a different truth. The wrinkling required an active signal from your nervous system, and that discovery led researchers to ask why such a mechanism would exist at all. The answer, supported by experiments with wet marbles and by the structural analysis of wrinkle patterns, is that wrinkled fingers improve your grip on wet surfaces. Your ancestors who had this adaptation could more easily catch fish in streams, gather food in the rain, and climb wet rocks. They survived. They pass their genes to you. And every time your fingers turn into prunes, you are witnessing a small but remarkable piece of evolutionary history written on your own skin. So the next time you step out of a long bath or climb out of a swimming pool, look at your hands. Those wrinkles are not a sign that your skin is waterlogged. They are a sign that your body is smarter than you think. Your nervous system detected that you were in a wet environment and made an adjustment. It constricted your blood vessels. It reduced the volume of your fingertips. It created drainage channels, all so you could keep your grip. That is why your fingers wrinkle in water.